Hello, my name is Les, and welcome to another episode of the Broken Broom Workshop. Today, I will be solving a dilemma with my table saw and my shaper. Both machines run on 220 voltage, yet I only have one 220 outlet available for these two machines. Instead of unplugging and plugging in each machine as I need it, I will be installing an on-off-on selector switch so I can select each machine independently of the other. In my case, neither machine will run at the same time, so this is the perfect solution for me. If I turn the switch one way, I can use the table saw, and if I turn the switch the other way, I can use the shaper. I will also be modifying and installing a couple of paddle switches, one on each machine. Hopefully this all works out, so stick around and we'll find out together. I have a switcher that's on, off, on. So I'm going to wire one plug to both machines. Now neither machine will ever run at the same time, so this should work without any problem. But we're going to see if we can try to figure it out. Hopefully this is all I'm going to need. If not, back to the store. I've got a paddle switch, two 20 amp, 250 volt single outlet, an outlet box, a cover. Then I got a dual gang outlet box and a flat plate for a single outlet that's gonna accept this. And then this will go into there like that. I got this type of box because of this mount. Mount it where these are up to the bottom of my rail here, just so that that switch is easily accessible. And of course, extra wire. And this is actual 12-3, the same wire that's on both of these machines already. You gotta love this thing right here. Everything is written in Chinese. Good thing it's not too hard to figure out. Okay, let's get started. I removed the existing plugs from the shaper and the table saw so they can be wired to the switch. Now, let me see if I can read Chinese. Not a chance. Even if I could read it, I can't see that small print. My eyes are not that good anymore. I got my meter out. I put it in tone mode, and I just started testing these wires. When it's in 0 or off, is the way I look at it, none of the terminals have continuity together. When I put it into 1, the terminals on either side at the top, when I say top, that's because this is up, have continuity, but in 1, the ones on the bottom don't. So when I switch it to 2, the ones in the bottom have continuity. So that makes it easy. Let me get my drill out and drill these two out, and then I actually need to drill one more hole. I attempted to use the little box that came with the on-off switch. I started by drilling the extra holes. After installing the wire grommets, I feed the wire through and start attaching it to the switch. At this point is when I realized the box was not large enough to accommodate all the wiring. I went and got a new box. What I ended up doing is I'll just cut out a hole and mount this directly to that. Then that gives me a lot more room in here for all my wiring. So we're going to hope that that works. Went ahead and put in a couple of my wire holders there. I need all 3 of these in here. Close enough. Got my cover, got my hole saws. All I'm going to do is just find a hole saw that's bigger than the terminal block here, but obviously smaller than my outside housing. Try to get it as close to the center as I can get it. Alright, and we go from that to that. I got the face of it all mounted up. However, the screws stick through. I don't really like sharp metal objects in here with the wiring. So I'm going to either find something to put over these, or I'm going to cut these off. What I did is I took the screws out, I cut the end of them off, the pointy tip, and then put them back in here, and then took my Dremel tool with a sanding disc on it and just kind of made sure that they were nice and flush. Screws are not going to poke in and tag a wire or something. Back to where we were. So what I did is I came in with the main power from the wall, and I just split it off, and I just did a pigtail here, and came out with two different leads on both my hot wires. And my ground wire, since the box itself has two grounds, I'm just going to utilize two grounds. This one from the wall is going to go to one side of the box. These two I tied together is going to go to the other side of the box. Hopefully this will give me a little bit easier time in trying to put this in here, because I got room in the box. So we'll give that a try and see what happens. Yes, and I know all you electricians out there probably are cringing, and this is not the way to do this. It's my way to do this. And I know these are supposed to be torqued down to a specific amount. Well, my hand and my screwdriver are my torque meter, so it's tight. Good enough. Got the box all put together, solid. Got everything clamped down, we're good. Next I'm going to go ahead and wire up that box with the two outlets, two receptacles, however you want to say it. Ran into a slight issue, but nothing that can't be solved with a little southern ingenuity here. My wire clamps here fit the 1/2-inch ones just fine, but I only have one on the bottom and only one on the top and one in the back, which doesn't do me any good. These are 3/4 inch, which are too big for my wire plugs. So what I did is I put one of these in here, and I already got one on this side, and then I drilled it out. I don't know if y'all can see that. I drilled it out to just enough to be able to take one of these and thread it down in there like so. I'm going to do that to the other one, and now I have my two places that my wire can be inserted. That's about how it's going to look. I'm going to have my two plugs up here, up out of the way, so they're not hanging down in front of my switch. That way they're up high. I marked the wire and stripped the insulation, cut the nylon strips back, and feed the wire into the box. What I'm going to do is go ahead and solder the ends of these, tin them up so they're solid, and then they'll act like a solid wire inside of here. Alright, so I clean my tip, and then I tin it a little bit to make sure it's got good conductivity. Put it on my wire, wait till the wire gets hot. Ever so often, just go and test it. It doesn't take long. Again, you apply the solder on the wire itself, not the iron, and it pulls it through. And that's it. I start by connecting the ground wire to a 20 amp, 250 volt outlet, then connect the hot wires to the terminals on each side. And there's the finished product. I've been having issues trying to figure out these buttons here. The problem with these switches is this is just an on-off switch. It is not the same type of switch that my table saw uses or that I want to set up for my shaper. My table saw switch, the original switch that comes with this saw, it's a low voltage type switch that controls a contactor, and this saw also has a thermal break and a safety cutoff where if the electricity goes off and the saw is powered on, if the electricity comes back on, the saw will not restart unless you push the start button again. The factory switch is basically a 3-wire that has a jumper between the start here and the stop here. The start is a normally open switch. The stop is a normally closed switch. But basically you have constant power coming through the stop switch. It's normally closed. The voltage coming through on one leg, coming out of the other leg also has voltage. That creates the stop circuit. So when you press the stop button, it opens this circuit and turns the saw off. Then it jumpers over and gives power to your start button. When you press this and it's a momentary contact, you already have power here. Press the button, it closes the circuit, puts power onto this wire, which then activates the contactor. And then once you release it, because the contactor is basically a big relay, it stays engaged until the stop button is pressed here. Once you break contact here, it breaks the circuit to the contactor and kills the power. Same thing with the electricity going out. If the electricity goes out, you lose power to this switch, which then releases the contactor. This switch here is very difficult to find, and if you do find it, it's not cheap. People are very proud of them. So I'm trying an experiment. We're going to see if this works, because on my shaper here, it's direct wired, which means it goes from the wall to the switch to the motor. There's no contactor, there's no relay, there's no safety, there's no anything. I'm a big proponent for safety, so I want to make sure that, if I'm doing this right, I'm safe. So I went to Grizzly and picked up a T24104 contactor, or it's actually they call it a magnetic motor starter. And basically what it does the same thing this one does, it's just newer technology is all. As you can see, the on switch is NO, which is normally open, and your off switch is NC, which is normally closed. It's hard to see, but it is written right here. What I'm going to try to do is extend this out to a paddle switch. In order to do that, I had to find a normally open and a normally closed switch. These don't do that. These are on or off. So basically I can't use them for this project, but I can use the front of it that has the paddle that I want. And I'm just going to modify it. So what I did is I picked up a couple of these switches here, and you actually get two switches. One is a normally closed, one is a normally open. Your start is a normally open, and your stop, this one happens to be the stop button because it's red, and I also have one for green, which is your normally closed. So it works out, it's the same switches that I need. I just have to modify my paddle switch and modify these switches and see if I can make them work. These switches are, not sure how to say the name, Appeal, I don't know. Anyway, there's your part numbers, there's your what you get with it. And you actually get two of these switches, two normally closed and two normally open. So I'm going to actually have extras of these. Buttons I'm not going to use. They go in there and they just twist and come out. There is this screw here, goes down in there and it screws into this bracket down here. I just undid the screw and pulled this out. I've actually already mounted one of these and I'll show you what it looks like. That is this right here. Here is what the paddle switch looks like when it's completely disassembled. And what I had to do, part of my modification, I went in here and I filled in these voids here in the switch. There's two little plastic, I don't know, raised parts here, and I filled them in with JB Weld. Put a couple of screws, and then I just kind of lined them up. The way these work, they have this little push tab, and it just pushes in and pushes back out. So I just needed something to push on that. So I lined it up to where the little red tab there is going to line up with my screw on the stop button. As you can see, the little screw there, if you can see that, hits the little red button when I push it, and it stops. I've already tested it. But what I'm going to do now is go ahead and mount the green one. And what I have to do is I need this bracket that comes with these switches, because that's how I'm mounting it to this plate. I'm going to go ahead and mount this on here. I've already got the holes drilled, so I'm going to go ahead and put these screws in. This area here, it was hanging on these screw heads. So I just took my Dremel tool and just kind of relieved a little bit of material right there. And now it pushes without hanging and everything like that. So I'm going to do the same thing to my green one here. Yeah, be careful with that thing. It'll pull these things out of your hand and grind you up too. Alright, let's see. Put my spring back in. And you gotta put this back in. And it doesn't seem to hang. Everything seems good. And let's test it with the voltmeter. Make sure that this is going to do what I want it to do. The on switch is normally open, so at rest, when there's nothing on it, when it's, you know, in its normal state, just sitting there, you should not get continuity until the button is pushed. All right, and the stop switch, which is normally closed, will have continuity at rest. That's what that means. Until you push the button, and then it stops. That part's done. So hopefully, if you ever have to make a switch, hopefully this will work. For some reason, I have not been able to find them. Maybe somebody else has them. I cannot find these paddle switches in a normally open and normally closed configuration. If this here, start button, stop button, if the start button was normally open, just like it is, but if the stop button, instead of it being just on off, if this was a normally closed switch, and that would be fantastic. So the next thing I'm going to do is figure out how to wire this to this remotely. This is my magnetic starter that I got from Grizzly. Here's the info on it. It's a 24104. It's up to a 5 horsepower motor. Mine's only a 3 horsepower, but we're fine. It says it's a 3-phase magnetic switch or magnetic starter. My system's only a single phase because I'm just residential wiring, but it is 220. And I'll show you how all that works together. Now, I am not an electrician. I don't claim to be an electrician. I dabble, which can be dangerous, but I have done this numerous times. I'm comfortable with doing it myself. Obviously, I don't recommend you try this at home. If you do not feel comfortable with electricity, please seek the advice or help or have a professional do this for you. The way that this wires in, you got power that comes in from the wall, comes to this side. This side of the switch goes out to your motor, and this particular unit has a built-in on and off switch that just uses these little paddles here that hits these buttons. Well, this whole unit is going to get mounted inside my shaper, so I'm not going to have access to those buttons, and I want a remote switch, obviously a remote paddle switch, which you've seen me how I did the modification to the switches to make the paddle switch work. But now it's time to wire this up. So what I did is I took just the cable that I'm going to wind up using. It's a 3-wire. It's a little overkill for the switches, but this is 312. And 312 means it has 3 conductors, and all 3 conductors are 12 gauge apiece. Now, this is standard wiring, which uses a green for ground. My switch doesn't use a ground. All it does is break the line voltage. Even though it's 220 coming in, it's only 110 going to the switch. So what I'm going to wind up doing is using the 3-wire, but The green wire, I don't want it to get confusing because it will not be a ground. You know, typical house wiring, your at 110, your black is hot, your white is neutral, and your green is ground. 220, your black and your white are both 110 each. Each leg is 110, so that makes 220. And then your green would still be your ground. Well, like I said, the switch itself doesn't use a ground. It's not breaking the ground connection. It's only breaking the line voltage, or the 110 connection in this case. So I'm going to put a piece of heat shrink over my green wire to make it look black. If I had red heat shrink, I would use red, because in these type of switches, usually you have black, a white, and a red. Or if you have a 4-wire, it would come with black, white, red, and green. So I'm just going to put a piece of heat shrink over each end so it looks like it's black. Let me go ahead and take this out. It's just held in with this little bracket. Let me get that wire out of the way. I don't know if y'all can see that. Hopefully that shows up. This little bracket right here that's also grounds. There's just one little screw down in there. Just that little bracket. That comes out. Now I can actually push that down in there. Alright, now it looks like I have 2 black wires. You will see electricians do this too. They'll use this when you need a 3-way switch or something, and they have to use the white wire as part of your power. You'll see a white wire with some red tape around it or something, or a red heat shrink or red marking to show that that's actually hot. I'm just basically doing the same thing. As you can see, I already put 2 of the weather-tight strain reliefs in here. The other 2 have knockouts, but I didn't knock them out. And I decided to drill a hole over here and just put in a wire clamp, strain relief there, mainly because it may be hard to see, but this knockout, I don't know if you can see that or not, there's just no, this one I might be able to get the wires to come through, but it would sure put a bend on them. I wasn't trying to stress my wires out that much, so I just did it in the side. You could do it however if you decide to do something like this. Kind of explain the way this works a little bit. What we have here, this side of your contactor has your line 1, line 2, and line 3. This is a 3-phase unit, but it can be used for not only a single phase, but also it's not 2-phase, but it's 220. If I'm not mistaken, 2-phase is not used much anymore. 3-phase kind of took that over. I know the electricians out there will correct me if I'm wrong, which I'm pretty sure I am. When power is applied to this, the magnet energizes, pulls this down, makes the contact through here, and sends the contact out what they call T1, T2, and T3. Not exactly sure what the T means. I think it means terminal, but I could be wrong on that too. But in this case, because I have a thermal break here with an amp setting on it, kind of hard to see, but there is a pin that comes out of here that goes into each one of these. You got one here, and one here. So basically these go through, power this, and then those are actually going to come out down here now. T1, T2, and then there's a T3 over here. If you're doing this with 110, you're just going to use line 1 in, line 1 out to your motor, and then your neutrals will connect together, and then your grounds will go together and actually ground to this plate here. As you can see, it's got the grounding symbol on it. This is what holds this down right here, but it's also your grounding point. For my purposes, which I'm doing is 220, I'm using line 1, and then I'm skipping over and I'm using line 3. And the only reason I'm using line 3 is because from the factory, they already have this jumper to cross. If you were to use this as line 1, or just a single phase, you would have to move this jumper over to your power source. And these are all isolated. Line 1, line 2, and line 3 do not touch each other across. They only make contact going down. But you would have to move this wire over to your power source because that feeds power to your switch. But what I'll do is one of my hot legs is going to come into 1. I'm going to skip the middle and I'll bring the other hot leg into 3, and then I'll just use T1 and T3 as my out to my motor. It's easier to see that as it's being connected. This is the wire that goes to my plug. This is the wire that goes to my motor. The original switch used to come out up here, and it was just an on-off switch right there. I'll wind up putting a plate over this for my wire to come out and go into my box, which where my switch is going to mount to. Weatherproof strain reliefs, obviously it's not going to be out in the weather, it's going to be in the inside the shaper, but this also keeps dust out of here, which this isn't going to keep 100% of the dust out, but it's enough. There's not much room that gets into this because of the size of this wire. It fills that up pretty good. What I'm going to do is go ahead and get the motor hooked up on this side, and then I'll come in here and hook up the power on this side. Now this green wire will actually be a ground because the motor grounds. Then I have my white and my black, which is one leg is 110, the other leg is 110, and that's going to be my 220. I'm going to do my black wire in T1 and my white wire over here in T3. Alright, let's hook up the main power. Take the strain relief off. And it's, goes without saying, or maybe I do need to say it. That's why there's warning signs on things. Make sure nothing's plugged in when you do this. My saw is actually not plugged in. Here's the plug for it. This is this wire here, which is from my wall. Obviously, it's not plugged in. Now, because I put my black wire into my T1 connector for the motor, I'm gonna put the black wire into the L1, line 1 on the contactor here. I'll put that in there. Tighten it up. Tug test. And then again, I'm putting my white wire in line 3, which it also has a jumper that jumps over to this number 13, normally open, which is a part of the relay, I believe, part of the relay that operates this. Alright, it's in number 3. Tighten it down. Tug test. Alright, now these two actually are connected together. Now let's see if I can get this back down into there, because now I've kind of got a lot of wiring in here and it's kind of tight. There we go. Now I've got it in there. Because I have two off switches, one here and one here, that are normally closed, which means there's power running through it all the time, and the way it turns the machine off is if you break that contact. These two switches have to be run in series, which means basically this switch has to go through to this switch, and then this switch has to go to the contactor, which then puts these two on the same circuit. So either one you press would turn it off. So it comes out one off switch, it goes through the black wire here, goes through to the green wire that will have black heat shrink on it, and then back to where this connects. I know it's confusing. I'll see if I can explain it a little differently. So I'm gonna go ahead and remove this wire out of the equation. But as of right now, I go to hit my green button here, and then I hit the off switch and it turns off. It does the same thing here. On, off. But what I like about this is if this is on and I kill power by unplugging it, When I go to plug it back in, it does not turn on. And that's the main thing that I wanted with this. That and the adjustable amperage rating and the thermal protection. So, I mean, this machine is fully protected now. But I'm gonna go ahead and remove this wire here from the contactor back here, and everything should be good to go. I will get this all put together with the switch, and we'll go over the whole thing and how it's all set up. All right, my two black wires, if I remember correctly, are going to go to my normally closed switch, which is my stop button. My white wire is going to go to my normally open switch, which is my start button. And then I have a jumper that jumpers between the two that provides power up to here. Here's my switch and plugs and outlets all mounted up. And yes, if you notice, in Broken Broom fashion, I did change the design again midstream. So what I'm going to do is I'm going to take the covers off, pull these apart, and show you what I did to change it. This box got changed. It was an aluminum box. I changed it out to the same plastic box that this one is, and I'll show you why I did that. Unplug the machine, make sure there's no power to it. The reason I changed this, originally the other box that was aluminum, my main power wire that comes from the wall came out of the bottom. I didn't want it coming out of the bottom and then circling back up and then going across. So what I did is I changed it to where the main power wire comes in through the top of this box here. This cable here is my cable coming from the wall. As you can see, all it does is run down into this opening here, comes down into here, and then feeds this. This wire runs my right side outlet, and this one runs the left side. So it basically wires the same. I just swapped out boxes. Like I said, it made this easier, allowed me to get my cable to run down behind and into this box, and to me it was just a little cleaner install. There we go. Let me get this all put back together and I will show you how it all works. To operate this, if I want to operate the table saw, come over here, switch that to 1, hit the start button here. Power's on the saw. I come over here, switch that to 2. My shaper. Stop that. And like I said, the starter that has the button still, it still operates and off. So, and the off button is actually the reset also. It's one reason I wanted that to stay working, is if that were to ever trip due to over voltage or a short or thermal or anything, that stop button is how I reset things without having to take it apart. Until the next one, y'all have a good one.